All right, gentlemen, we're going to look at finding the volume of a couple of these figures. All right, so let's open this out. Let's talk about it. Okay, this is hexagonal base prism. Okay, so the volume formula is equal to base area times the height. That's the volume formula for all prisms, base area times height. And the base is a hexagon. Area formula 1/2 the apothem times the perimeter, okay, times the height. We have the height is 3. We do not have the apothem, nor do we have the perimeter. So what I'm going to do is remind you of how we did that previously. Over here, a little sidebar. I'm going to construct my hexagon, okay. In my hexagon, I'm going to know that that is built on 6 equilateral triangles, okay. With that equilateral triangle, the length that I have of 3 is meaning to be shown as this length, okay. And if I enlarge that equilateral triangle right here, okay, here's my equilateral triangle. This length is 3. Since it is equilateral, all lengths are 3, which means every side here is 3. So my perimeter is, of course, 3 times 6, which is 18. What's left is my apothem, which is right here, okay. The apothem comes down, divides this into a 1.5 length. My 30-degree angle is here, so my apothem is 1.5 the square root of 3. So I have everything named now. My apothem is 1.5 the square root of 3, and now I have everything I need. So I have the volume 0.5, that's the 1/2, times the apothem 1.5 times the square root of 3 times the perimeter, which is 18, times the height, which is 3. So all you got to do is multiply those all out, and you have the volume of that, okay? Let's take a look at this guy, okay? This is a different type of figure. It's called a composite figure. You should be able to reason that if we took the rectangle as defined here and took out these 2 semicircles, then we'd have that figure. Not quite what I have drawn there, but close enough, okay? Try to improve on that a little bit. It's hard to draw on this screen, okay? So here's a little bit better. Okay, so that's the cross section, that's the base. That's the base, okay? Now, of course, the base does not include these lengths here, so I'm going to take those out, okay? And basically, what is that? That's a rectangle minus, well, it's minus 2 half circles, so it's minus a full circle. Rectangle minus a circle. That's all it is, okay? What do we have as the dimensions of the rectangle, okay? Well, the one dimension is 10 inches. The other is this length. That length is just the diameter of the circle where the radius is 4, so that's 10 times 8, okay? That's 10 times 8. minus the circle area, and the circle is pi r squared, where r is equal to 4. R is equal to 4 here. So it's pi r squared, it's 16 pi, okay? So then that's 80 minus 16 pi, which is the base area, okay? That's the base area. And so the volume is the base area times height. And the height is given as, I think it's 3. So the volume is going to equal 3 times 80 minus 16 pi, okay? We had discussed this one in class. The base is a circle, less a square. 45, 45, 90 comes into place. This figure, okay, well, all right, basically it's two figures in one. The top portion is just a semi-cylinder, if you will. It's a half of a cylinder. The radius of which is 3.5, and the length of which is what? 8 less 3.5. The bottom of it is basically this same figure, one that we discussed in class, okay? And this is a little awkward with the mixed units in feet and inches. Basically, the 6 inches here is 1/2 of a foot, okay? And the 10 inches is 10/12 of a foot, so that's 5/6 of a foot. So I would put that in there, keep that in there, okay? So you need to think about these. They are problems you should be able to do, and you need to do, okay? So get them done.